guys, today I'm going to teach you all about expanding and factoring expressions. By the end of this lesson, you will be able to use the distributive property to expand and factor linear expressions with rational coefficients. We'll start out with another example using food. Let's say that I am going out to eat with a friend. Let's say my friend's name is Amber. We're each going to go out to eat, and I'm taking my husband and she's going to take her boyfriend. Me and my husband are each going to get a burger, fries, and a soda. So that is 2 burgers, 2 fries, and 2 sodas for us. Amber and her boyfriend are going to do the same thing. They are each going to get a burger, they're each going to get a fry, and they're each going to get a soda. So instead of needing pictures out on my screen for all of those different things, I know that I just need 4 of each of the items. So now when someone goes to order for us, they can just say we need 4 of each of these items. One way that can be written is with parentheses and the number of the amount of items on the outside. So when I go to order, I will say I need 4 of each of the following: 4 burgers and 4 fries and 4 sodas. So some of the math we're going to see today is going to be written in this format with a number outside of the parentheses, and then some other numbers and variables, some other terms will be inside. And then we'll use what we know to expand and factor those. Let's go ahead and get started with our notes. The first question says, simplify the following expressions by following the order of operations. The order of operations say to do parentheses, then exponents, multiply and divide from left to right, and then add and subtract from left to right. So looking at number 1, I see 6, and then the quantity 3 plus 9. Since there are parentheses, I'm going to go ahead and do what is in the parentheses first. 3 plus 9. 3 plus 9 is 12, and then I just add on that 6 outside of the parentheses. Now, I know anytime that there's a number right next to parentheses, that means multiplication. We don't have to have the X or the dot multiplication symbol. So in this case, we are doing 6 times 12. 6 times 12 is 72. There is another way to work these problems out by using what is called the distributive property, where I distribute the 6 to both of the numbers that are inside of the parentheses. In this problem, I would have 6 times 3 and 6 times 9. 6 times 3 is 18, and 6 times 9 is 54. When I add those together, I'm going to get the same 72. Let's go ahead and look at number 2 together. Here I see inside the parentheses I have 9 plus 2, so I can simplify that to 11, and I've still got that 5 outside of the parentheses. And now I know I just have 5 times 11, which is 55. Go ahead and pause the video and try number 3 on your own. Press play when you're ready to check with me. This one was a little different since I was subtracting inside of the parentheses, but the process is still the same. I can subtract 8 and 4 to get 4 left in my parentheses, and then I have that 2 outside of the parentheses. And then 2 times 4 is 8. If we look underneath those problems, there's a question that says, how is 7 times the quantity of x plus 2 different? Brainstorm how this problem could be simplified. So in this problem, the variable x has replaced a number. However, the process remains the same. We can do 7 times x and 7 times 2. The distributive property allows the number outside of the parentheses to be distributed to the terms inside the parentheses. Distribute just means that something is shared across different pieces. So in this case, in the last case, we were sharing the 7 with the x and with the 2. But at the bottom, we have another example, 3 and the quantity of 2 plus 7. So we can distribute or share that 3 with the 2 and with the 7. So that either way, we get 3 times 2 and 3 times 7. Another example is 3 times the quantity of x plus 7. Again, we can distribute or share that 3 to both pieces, 3x plus 3 times 7. Next, we have an example that is very much like the one I showed you on the previous screen before our notes started. It says each of the 4 members of the Robinson family order a drink, 2 slices of pizza, and an ice cream cone. When I distribute, I like to draw arrows from the number outside of the parentheses to each of the items inside of the parentheses so that I don't forget to multiply it by one of them. So here I'm going to do 4 times the soda plus 4 times the 2 slices of pizza plus 4 times the ice cream cones. After I do this, I use their variables, and I know that I'm going to need to order 4 drinks, and 8 pizzas, and 4 ice cream cones. The next couple of problems show us one way that we can solve these by using area models. You can see that on the left side we have 5, so that would be like the number outside of the parentheses, and then the two numbers at the bottom, or the two terms, 3x and 2, that's what would be inside of the parentheses. Here when we distribute 5 to 3x, or share that 5 with the 3x, I can multiply the 5 and the 3 to get 15. When you do this, though, it's really important that you keep your variable. Then I can also do 5 plus 2. 5 times 2 is 10. And since that's a positive 10, I'm going to add a plus here so that I know my final expression is 15x plus 10. Looking at the next example, I want you to go ahead and tell me what would go in those two boxes. Press play when you're ready. On this one, I can do 7 times x, which is 7x. This one was just a little bit different because I have 7 times negative 9. We learned about this in our first unit. I would just multiply the numbers 7 and 9, which is 63. Since one of them is negative, I need to have a minus sign or a negative sign. That just goes in between the two terms, so that my simplified expression is 7x minus 63. In the next set of problems, we're going to simplify the expressions using the distributive property. In number 4, I'm going to distribute or share this 5 to both the 6x and the 9 that are inside of the parentheses. Once I distribute that, I get 5 times 6x plus 5 times 9. The 5 times 6, I can multiply 5 and 6, which is 30. We have to remember to keep our variable, so I've got to keep that x. In the other part of my expression, I have 5 times 9, which is 45. Let's go ahead and look at number 7. On number 7, we have a fraction as the number outside of our parentheses. It doesn't matter when it's a fraction. We know that's still just a rational number, and we can still multiply with rational numbers. So I'm going to take that 1/2 and distribute it to both the 8 and the negative 6j. 1/2 times 8 is 4, and 1/2 times negative 6 is negative 3. We have to keep that variable j with our number, though. Also look at number 8, since that one's just a little bit different as well. I'm going to look and distribute this 8 to the p, and to the 7, and to the 2q. So this is kind of like that last example we had with the pizza and the drinks and the ice cream cones. I still distribute that number to everything that's inside of the parentheses. Here, I'm going to have 8 times p plus 8 times 7 plus 8 times 2q. Once I simplify that, I get 8p plus 56 plus 16q. Go ahead and pause the video and try 5, 6, and 9 on your own. Press play when you're ready to check with me. On number 5, once I distribute that 4, I would get 12k minus 8. On number 6, I have a 1.5 to distribute, and I would end up with a 9t plus 3. And finally on 9, I have a 4 to distribute, and I would have 12.8d minus 40. The next section says to simplify the expressions using the distributive property and then combine any like terms. So we're going to do what we've been practicing in this lesson, as well as combine like terms that we learned how to do in the last lesson. I'll go ahead and start with number 10. First, I see that 6 next to the parentheses, so I'm going to distribute that 6 to the numbers inside of the parentheses of the terms. 6 times 4c is 24c, and 6 times negative 2 is negative 12. Then I've got this final term already outside of the parentheses, that plus 10, so I'm just going to bring it down, plus 10. And now we can look to combine any of the like terms. Remember that I like to draw circles around each term and then look to see which ones are the same. And if I'm able to, I also like to color code. So once I go through, I see that I only have one term with a C. So that is my only green 24C term. And then I have the minus 12. Remember, we've got to make sure we include that sign in front of the number. And I've got the plus 10. Since those are just numbers, I know I can combine those. This will give me a final expression of 24C minus 2. Let's go ahead and try number 11 together. First, I go ahead and distribute that 6 to the terms inside of the parentheses, 6 times 3b, and 6 times 7. And then I just went ahead and brought down that third term, plus 5b. Once I simplify this, 6 times 3 is 18. Keep the variable, so 18b. 6 times 7 is 42. And then I just bring down the other 5b. Now I can circle my terms and determine which ones are similar, which are like terms, so that I can combine them. I saw that I had 2 terms with a b, so I circled those in green, 18b and 5b. I can combine those terms to get 23b, and then we just add our final term plus 42 to the end. Go ahead and pause the video and try number 12 on your own. Press play when you're ready to check with me. After distributing, you should get 3x plus 8x plus 14. Then I noticed that 2 of my terms have the same variable x, so I can combine those. 3x's plus 8x's is 11x's, and then I can just add that last term of 14 to the end. All of that first part of the notes was about expanding expressions, and now we've kind of got the other end of that, kind of like the opposite, where we can factor expressions. Expressions can be factored to remove the common factor. This is how we undo the distributive property. The steps for how to factor an expression are listed below. 1 is to determine the greatest common factor between the values, and then 2 is remove the greatest common factor by dividing each term by it. In this example, I have 6x plus 15. When looking for the factor, the greatest common factor, you can make factor trees. Here's an example for 6 and 15. Once you make the factor tree, you want to get the smallest factors for each number. For 6, I have 2 and 3, and for 15, I have 5 and 3, because 2 times 3 is 6, 5 times 3 is 15. Next, I'm looking for the greatest common factor, so I find that they have a 3 in common, so that is my GCF. Once you do that, the second step is to divide each term by it, so we can take 6x divided by 3. 6 divided by 3 is 2. We've got to keep that x, though. And then on the other end, we've got 15 divided by 3, which is 5. So this is what the final factored expression would look like. In the next 2 questions, we've got area models, 4x and 16. I'm going to go ahead and set up factor trees to find out the factors of 4 and 16 to find my greatest common factor. Since each of their smallest factors ended up being 2's, I need to look for what they have in common. The 4 has 2 2's, and the 16 also has 2 2's. Those are my common prime factors, and now since they each have 2 of the 2's in common, I can multiply those. So 2 times 2 is 4, giving me my GCF of 4. Using an area model, I want to put that GCF outside of the box. So my GCF is 4. In this case, they don't have any variables in common, so I can't also pull out a variable. Now I can determine what goes on the inside of my parentheses by dividing. 4x divided by 4 is 1x, but we don't need that 1 coefficient, so I'm just going to write x. And then 16 divided by 4 is 4. Since it's positive, I'm going to add that plus. Go ahead and pause the video and try this for the next area model, 12x and 18. Press play when you're ready to check with me. Once I set up my factor trees for 12 and 18, I get that the 2 prime factors they have in common are 2 and 3. And remember, prime just means they can only be divided by 1 in itself, like 2. 1 and 2, 3, 1 and 3. So the ones they have in common are 1, 2, and 1, 3. So I multiply those together to get 6, and that is my greatest common factor. Now I can divide each of those factors by 6, so my GCF being 6 on the outside, 12x divided by 6 is 2x, and 18 divided by 6 is 3. We'll go ahead and look at number 13 together. It says to rewrite each expression as a product of 2 factors. So I'm going to look at the 6 and the 2. I can see that my greatest common factor here is going to be 2. Then I can take each of those terms and divide it by 2. 6a divided by 2 would be 3a. 6 divided by 2 is 3, and we've got to keep that variable. Next, I can do 2 divided by 2, which is 1. Since it's a positive, I'm just going to add a plus there. Go ahead and pause the video, try this for 14 and 15, and press play when you're ready to check with me. For number 14, the GCF was 3. They each had 1 3 in common. 24x divided by 3 is 8x, and negative 9 divided by 3 is negative 3. On 15, I've got 10 and 35. Their GCF is 5. So outside of the parentheses is 5, and then 10x divided by 5 is 2x, and 35 divided by 5 is 7. Go ahead and summarize today's lesson in 2 to 3 sentences. That's it for today's lesson. If you made it to the end of the video, let me know, would you prefer an ice cream cone or a snow cone? In this lesson, we learned to use the distributive property to expand and factor linear expressions with rational coefficients. We used the distributive property, we reviewed how to find the greatest common factor, and we used these to both expand and factor linear expressions. We looked at this with pictures, through area models, and with expressions. Let me know if you have any questions. Bye, guys.